You just learned how to determine the mass percent composition of the elements within a given compound. This is going to be a different approach in which we can determine the mass of an element within a compound of a given amount of that compound. So by recognizing that there are mole relationships within the elements of the compound, we can create conversion factors from the chemical formula. So the subscripts of the chemical formula indicates to us the number of moles within 1 mole of that compound. So if we have a question here that asks, calculate the mass of oxygen in a 7.2 gram sample of aluminum sulfate. Now, aluminum sulfate contains how many oxygen atoms? Let's see. We have this subscript 3 outside the parentheses and a subscript 4 next to the oxygen. So the total number of oxygen atoms within aluminum sulfate is going to be 12 oxygen atoms, okay? So that 12 oxygen atoms indicates to you that you have 12 moles of oxygen within 1 mole of the compound aluminum sulfate. So this gives you a relationship. 12 moles of oxygen is in 1 mole of aluminum sulfate. And of course, you can apply the subscripts of the other elements as well. There are 2 moles of aluminum in 1 mole of aluminum sulfate. There is 3 moles of sulfur in 1 mole of aluminum sulfate. But since this question is asking us about oxygen, I'm showing you the relationship between oxygen within the compound. So when we write a relationship like this, we call this an equivalence, and all equivalences can act as conversion factors. Okay? So if we are given a particular mass of a compound, we can determine the mass of an individual elements of that compound as long as we can determine the amount of moles of the compound, and from moles we can convert it to moles of the elements, and then from moles of the element we can convert it to grams of the element. So let's write out our plan, because you may have got a little bit lost in there because I said that a lot. Okay, I said a lot of stuff there. So our plan is going to be take our given value, 7.2 grams of aluminum sulfate, and convert that amount of grams into moles of aluminum sulfate. Then from moles of aluminum sulfate, we can use the equivalence to change moles of aluminum sulfate into the amount of moles of oxygen. And then from moles of oxygen, we can convert to grams of oxygen using the molar mass of oxygen. Okay, so this is going to be important to understand because this is a brief introduction into how you're going to be learning stoichiometry. In stoichiometry, you're going to be converting from grams of one substance to moles of that substance, and then moles of that substance into moles of another substance based on how substances react with each other. So by recognizing and understanding these steps will then be applied later on as we get into stoichiometry. Okay, so what we're recognizing here is that right now we're looking to determine the amount of oxygen within a given compound based on the relationship of the amount of moles of that element within the compound. Okay. So here's our plan. Okay, so this is our plan. We're going to focus in on taking the plan and taking it one step at a time. So you may have recognized that in a previous problem, I had you determine the mass percent composition of aluminum sulfate. So you most likely have already calculated the molar mass of aluminum sulfate. If you're not sure how to calculate the molar mass of aluminum sulfate, remember, of course, we look at the elements that make up the compound using the subscripts and multiplying those subscripts by the mass given on the periodic table. So 2 aluminums, 3 sulfurs, and 12 oxygens. Add up those masses and you'll get the molar mass of the aluminum sulfate, which is what is needed in our first step of converting grams of aluminum sulfate into moles of aluminum sulfate. So I'm going to start with the conversion using 7.2 grams of aluminum sulfate. Okay. And we're going to change grams of aluminum sulfate into moles using the molar mass. The molar mass of aluminum sulfate that I have calculated previously is 342.14 grams. So we're going to start with putting the grams on the bottom to cancel diagonally. 342.14 grams of aluminum sulfate. Remember, it's important to write the chemical formula in here because we're changing from one substance into an element, the amount of the elements within that substance. So I'm keeping the chemical formula here. Per 1 mole of aluminum sulfate. Now we've canceled grams of aluminum sulfate. Now we got to moles of aluminum sulfate. In our next step, we're going to convert moles of aluminum sulfate into moles of oxygen using the subscripts that we determined. 12 oxygens are in the compound. So that means 12 moles of oxygen is in the compound within 1 mole of the compound. So 1 mole of aluminum sulfate is equivalent to 12 moles, or it contains 12 moles of oxygen. Okay, so that's the relationship there. Now we're able to cancel now moles of aluminum sulfate to now give us the amount of oxygen within the aluminum sulfate. And now the question asks for mass. So remember, the units of mass is grams. So our final step is converting our moles of oxygen into grams using the molar mass of oxygen. The molar mass of oxygen is 16.00 grams per 1 mole of oxygen. Cancel out your units of moles, and now we're left with grams. Now that all the units have been properly canceled, we can now use our calculator to solve. So we're going to begin with 7.2, divide by 342.14, times by 12, times by 16. And when you do this, what you will get is 4.3 grams of oxygen. So this will be equal to 4.3 grams of oxygen. Okay. So of 7.2 grams of aluminum sulfate, 4.3 grams of it is the oxygen atoms, the mass of the oxygen atoms in the compound.